here we have the first wave peaking, then back to the axis, valley, back to the axis, peak, back to the axis, etc. And we're going to draw the reflected wave. So you might think about how that reflected wave would be drawn. Okay, here we have the reflected wave, which is exactly 180 degrees out of phase at this point with the original wave. Now, we don't consider the wave as having originated from any particular point, from here or from there. It originated out there someplace. These waves have just been coming toward each other, and they happen to be crossing right in front of our very eyes. Okay, so original wave going this way, reflected wave coming this way. Now, what do they add up to? Well, in this case, for any point on the x-axis, we've got a point above the x-axis on one wave, a point below the x-axis on another. The principle of superposition simply says that we add the y displacements of the two waves, and we get the net displacement, which in this case is 0. So we simply draw this orange line across the axis. Now, we're going to shift each wave a quarter of a wavelength. Now, what's a wavelength? A wavelength is a full cycle. So a wavelength is from peak to peak, or from valley to valley, or from a point where we're at the origin going upward to the next point where we're at the origin going upward, looking at the white graph here. So that the wavelength, I'm going to label it here. Okay, not sure I can even see that on the board. Let's raise the camera a little bit. It's not written real dark. But anyhow, you see there's lambda. It goes from here to here. Full cycle of the wave. Now, we're going to proceed to shift this wave a quarter of a cycle. We see that the grid here is marked off in quarter cycles. It takes 1, 2, 3, 4 of these distances to make a complete cycle. So each of these distances represents a quarter cycle, to the extent that the distances are consistent. Now, freehand drawing are not great. So you might want to do that. Okay, we see that this peak of the red wave has moved over a quarter of a unit to this point, and the wave continues as it must. And we see that the wave is completely in phase, so that it reinforces the other, so that at any point, if we add the two y values, we get a y value that's twice as great as it previously was, or twice as great as that of either of the two component waves. Trying to keep this going without screwing it up. Okay, I made it. So now we have this wave. Now we're going to move another quarter of a unit and see what happens. Another quarter of a wavelength. As a matter of fact, we're going to go ahead and move 2 quarter wavelengths. I said that wrong. We're going to move another quarter wavelength here and another, excuse me, another quarter wavelength here. Okay, I believe I've got the white wave 1/4 wavelength to the right. The peak was here, now it's here. Peak was here, now it's here. It seems like I've got it all the way across. And now this peak will have moved to here in the next quarter wavelength. And this peak will have, something's wrong. What's going on? This peak has moved to here. This peak will have moved to here. Okay, this peak will have moved to here. I don't know what I was looking at. This peak will have moved to here. I've been looking at these too long today, apparently. Okay, and now we bring the red back so that this peak will move to here and then to here. So I'll do that off camera. And I think that does it. This peak is here, then it's here. And this peak, well, this peak is here, then it's here. So we can take each peak. White peaks here, 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 or here, 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 here. Red peaks, well, here's one here, then, oh, wait a minute, here, okay, no, here, then here, then here, then here. Okay, I'm looking at the board at kind of an odd angle there, but I of all people shouldn't be getting confused. Okay, well, what does this do to the shape of the graph? Well, here we have the waves being totally out of phase again, where one is up, the other is down, and they seem to have equal amplitudes, so that the waves simply cancel each other out. They add up to 0 at every point, so there's no displacement from the axis. And here, of course, the waves reinforce. So we're going to have this very similar to what we saw before. But there is, of course, a difference. And you might want to think about what that difference is, but there it is. What's the difference between this wave and this wave? Well, this wave is down where this one was up. So again, this is the behavior I showed in the first brief clip, where we have, let's say, between these two lines here, we have level, then we have a positive, an upward peak, then it's level, then a downward peak. And of course, the wave goes through every position in between. You can imagine how it would deform from here to here, back to here, and down to here. And of course, we could move these waves 1/8 of a wavelength, let's say, each time, and approximate the sequence of superposed waves, seeing how the waves would form this sort of oscillatory behavior.